So this talk is not going to be about Ceph nor CloudStack. It's going to be a combination of how to use Ceph and CloudStack combined and what kind of network technologies you might need to get this in a flexible, reliable situation. So it's going to be about VXLAN, BGP, and EVPN. Who here is using VXLAN and BGP in their deployment? Anybody using with EVPN? We got a hands already. 3 hands, so that's good. So correct me if I'm wrong at some point. So, who am I? I quickly jumped over. So my name is Wido and Hollander. I'm from the Netherlands, or they would still say I'm Dutch. I would call myself a Ceph, CloudStack, and IPv6 guru. So all the stuff I do is IPv6 based. I have a mentality to do IPv6 first and then IPv4. And I work as a Ceph trainer and consultant, CTO at 42On. So the company 42On, quickly, we are specialized in Ceph. So we do Ceph consultancy training and emergency assistance. And that's all about it. If you want to know more, go to the website or talk to me or talk to Wout, my colleague. This talk is going to be about a different company which I founded in 2004, PC Extreme, a Dutch hosting company. It started as a joke when I was 15 and it grew out to be quite a large company. So we have about 80k customers and we run about 20,000, I checked yesterday, 25,000 virtual machines on our CloudStack deployment with Ceph. And we manage about 3 petabytes of Ceph storage running on our deployment. That's full NVMe, so we're not using any HDDs anywhere. It's full SSD NVMe deployed Ceph storage nowadays. But we have some challenges when growing our systems. Because our traditional cloud, which we have still based on CloudStack and Ceph, is a layer 2 network. We have some challenge with scaling this layer 2 network because redundancy becomes a problem when you want to stretch out layer 2 over too many racks. You need to use stuff like spanning tree, and that causes loops, and you're tied to vendor specific things, and we don't like vendor specific things because we use open source CloudStack, open source Ceph, but we are still tied to these black boxes called switches and routers from vendors which lock us into their proprietary software. So how do we get away from that? So we wanted to eliminate layer 2 due to redundancy and scalability things, but also due to the vendor lock-in we get on that equipment. And there's a 4K limit usually on devices for the amount of VLANs you can create. And as we were scaling out, we were actually running out of VLANs. And not so much that we're using all the 4K, but you want to have some number plan in your VLANs, and that became very difficult with layer 2. So we said layer 3 networks are better. They're more flexible, reliable, scalable. Oh, they're just better. That's it. And I can talk all kinds of stuff. I think they're better to use in larger deployments. So we set out a project last year calling Compute 2.0 where we want to iterate a new iteration of our cloud deployment. So the existing deployment was layer 2 and the new deployment need to be flexible, better scalable. And then we said less or no layer 2 networking, and as open source as it can be. And the underlying network should be IPv6 only. So you might wonder why IPv6? Well, why use technology of the past, of the future? Yeah, that's what I meant. Yeah, why use Ceph and CloudStack with IP, which is from the past? So this is a sticker which you actually can find on the internet. You can buy this sticker and you can put it on equipment which is not IPv6 ready. But anything you buy nowadays is IPv6 ready. So just use it. Anyway, VXLAN. This is a quote from Wikipedia, so you can find this on Wikipedia, but it's actually capturing layer 2 packets in layer 3, sending them over UDP over the network. So you kind of have like VLANs, but they're encapsulated inside UDP packets, and you send them over the network. Actually showed here. So your NTU of the network needs to be larger than 1500 bytes. Who's using jumbo frames in their network? I figured so. If you do a cloud deployment, you're probably using jumbo frames. So we use an MTU of 9216. And if you create VLANs inside VXLAN, they are called VNIs, Virtual Network Identifier. Well, you can create 16 million VNIs inside a network before you run out. So that's a big difference. We're going from 4K to 16 million. If you start looking up some documentation with VXLAN, it will use multicast. It will use a multicast group to exchange IP information, MAC address information, and where to find each VNI. This, however, becomes a scalability problem as well, because multicast, if you scale out too big, you'll get a lot of multicast chatter on your network. And that is a scalability problem again. And remember, we said we want to have a scalable network where we are not tied into vendor-specific things, because some vendors do some magic multicast stuff, and sometimes it's not routable. They don't allow routing multicast over different layer 2 segments. So we found a solution. VXLAN, BGP, and EVPN. Using the Border Gateway Protocol, BGP, like the whole internet is built on, you can exchange this VNI, IP, and MAC information to different hypervisors and different hosts. So that allows us to scale VXLAN over different layer 2 and layer 3 segments in our network. And we can even route them multi-data center if required. We don't do so, because we build what we call availability zones, like all the big clouds do. We on purpose do not route VXLAN to different data centers, so if something goes wrong, it's isolated to one data center instead of multiple data centers. We have 5 data centers in Amsterdam where we run, one in Brussels, then in Antwerp, we have Miami, we have Barcelona, but we do not route the VXLAN to these different data centers. It stays inside one data center just for having failure domains. So if you would go to VXLAN EVPN again, I was searching for some text. I said, well, let's go to the Juniper website. That's way easier than typing it myself. But what EVPN does, it allows you to connect these layer 2 networks together with EVPN combined with BGP. You can route them through your existing network as long as you use something like jumbo frames. Your MTU needs to be larger than 1500 bytes, otherwise the packets won't fit. So I'd say it's liquid gold if you get this. It's the best you can get for networking, a flexible, scalable networking solution. Google it, because I can tell you a lot about how the stuff works, but that would be a long talk about talking about how BGP works, how VXLAN works, all the information. I'm here to inspire you to look into it and say, hey, this sounds interesting. If you start Googling for this, you'll find a really good blog post from Vincent Bernard. He has an awesome blog post about how to use VXLAN and BGP and EVPN. So I recommend looking him up. I think the link is at the end. So then we use CloudStack and we want to use VXLAN. How does it work? Well, we put a lot of work into the 4.12 release to get VXLAN properly supported. There was VXLAN support in there, but it was buggy at some points. So we made a few commits and fixes. You also will need a customized script, because the default deployment for CloudStack is that it uses multicast for the networking to route. And as I said, multicast has scalability problems. That's why we say we use BGP with EVPN. So we have a modified script which you can find on our GitHub. The link is in there. We'll send the slides out later. I'll send my slides to Steve, so Steve will make sure these slides get sent to you, so you have the link. And then we use BGP on the host, and we use FRR routing, which is actually a fork of Quagga. Anybody familiar with Quagga or Zebra, the BGP daemon on Linux? Hands going up again. Yeah, that's good. It's a fork. Quagga wasn't maintained very well, so there's FRR. And what does FRR? Learns new VNI. So when a VM is started, CloudStack sends the VNI information down to the Linux kernel, and then the FRR daemon is actually, it learns that this VNI is now available on this host, and using BGP, it will announce this information to its peers, telling, hey, this VNI, this VM can be found on my host. Will be done within a few milliseconds after the VM started. So you have, if you live migrate the VM to a different host, BGP will now tell that the VM is on a different host. This is outside of the scope of CloudStack. It's all handled by the kernel, by the routing protocols underneath. It's just done by KVM. Security grouping also works with CloudStack, and it has IPv6 support. We also always make sure that IPv6 works. But then we are still done. What do we use for switching? So we went for Cumulus Linux. Anybody familiar with Cumulus Linux? Yes, hands again. That's good. It is a Debian-based operating system for ONI switches, which is called Open Networking Environment. And you can just buy switches from all kinds of vendors, from Dell, from what's that? Yes, I was looking for there's a Dutch company called Quanza, so it's kind of a Quanta indeed. Supermicro has those switches, I think HP has them, and there's a lot of Taiwanese brands which are building these switches. It's actually quite funny. You just get a switch which has a mini computer in there, you install your operating system, and you can just do whatever you want. It is actually a own Linux system. You can just SSH into your switch, like you could do with any switch. We just have root access, and it's a Linux system. So we use Salt for provisioning these switches. So there's Puppet, and we use Salt for provisioning. So we just install the switch, we run Salt on there, and it provisions the whole switch with all the VNIs, all the BGP configured on that switch. The benefit is we can just take out the switch, put in a new one, run Salt again, and it's configured. We can also mix different brands. So that's where we go. Because we use Cumulus Linux, we can take any brand of switch and just put it in, and it works. So we're not using any vendor-specific stuff from Dell or Supermicro in this case. So what kind of switches do we use? We went for the Dell switches with 32 times 100 gigabit of network. And you would say that's very expensive. But if you look at affordable, they're about 3,500 euros for each switch. And then you get 32 times 100 gigabits. I see that a lot of people writing again, we'll be sending out the slides. So you get all these slides in your mailbox.
You still got to buy the license for Cumulus, though.
Yes, you still need to buy the license for Cumulus, but you can negotiate with them. But the license is about 3,000 for the switch as well. So in total, you'll be paying about, let's say, 7,000 euros. That's going to be about 6,000 pounds, I think, for that switch, or dollars, about $8,000 for such a switch. I don't think that's very expensive for 32 times 100 gigabits.
Cheap.
It is actually cheap, yeah. You should look, if you start looking into ONI switches, take a look at what kind of chipset is in there. In this case, there's a Broadcom Trident 3 chipset. There's also a 2, but the 3 chipset just is a bit faster and a bit better with routing VXLAN. But these switches have VXLAN offloading in the chipset. And if you look at Cumulus, all it does is actually program the chipset. So there's an Atom CPU and 4 gigs of memory on a small board which you use, and that Atom CPU is not in a data plane. It's just there for management. It configures the chipset, the Broadcom chipset, and then it runs. But it's a Debian system, so you use if up, if down to configure IP ports like you're used to with a Debian system, but it's just a switch, and it has microsecond switching times. So we use them for two purposes. We use them for our core routers in our deployment and for top of rack. Because they are affordable, we use them for top of rack as well. So everybody likes pictures, so this is where you get a 1U box with just 32 ports of 100 gigs. That's what you get. But that's of course just a switching. So where do we go towards the hypervisors? Because of course if you build a cloud, you want to have an affordable system as well. The switches need to be affordable, but the hypervisors as well. So we started out for a quest for hypervisors, and I am an AMD fan. So we use a lot of Supermicro stuff, and we came up with the dual Epic system from Supermicro, 1 terabyte of memory in there, 10 times the Samsung 2 terabyte SSDs for local storage. So we use a mixture. Some VMs use local storage, and others use Ceph storage. So we have a mixture, so there's local storage inside the hypervisor, and then we use a Mellanox Connect X5 NIC in there to do the network handling. So we have 2 times 100 gigabit per hypervisor in that. I would say it's affordable. It's about 17,500 euros per hypervisor. Yeah, it's a lot of money if you need to pay this by yourself, but I think for a hypervisor itself, I got a quote last week for a new hypervisor was 16,500, so 1,000 less, but that might be a one-time quote, I'm not sure. So again, everybody likes pictures. You know, 1U box. Can you imagine 15 years ago you would have a 1U box with 64 cores and then 1 terabyte of memory in 1U? No, I think nobody would no. And then we're using Ceph as well, because we have, like I said, we have the local storage and the HA storage. Again, Supermicro, in this case, a single AMD Epic, 128 gigabit of memory, and there was the 4 terabyte Samsung NVMe's, and then they are using 10 gigabits, because we don't need that much bandwidth for the Ceph servers. 10 gigabits is still sufficient. What we see, we mainly need lower latency. We might switch to 25 gigabits, but we were lazy because the 10 gigs is built into the server. It's still sufficient for us. That's why we use it. And again, I would say it's affordable, 8,500 euros for a single machine. I usually name the prices because then you get a better feeling of how to build such a cloud. And again, pictures, 1U machine, single CPU, a bunch of SSDs in there, and that's how it's done. So each machine, hypervisors 100 gigabits, Ceph OSDs 10 gigs. So the networking, what we have on the host. So both the hypervisors and the Ceph servers, they run BGP on the host. Again, we use FRR routing, so there's no LHCP, no bonding, no teaming. There is no layer 2 towards the host. Yes, of course, from the switch to the host, that's a single layer 2 network, but that's all it. Over one wire, switch to host. That's the only layer 2 we have. And all hosts, they announce their loopback IPv6 address, so a /128, through BGP. So they simply announce towards the switch saying, hey, I have this address. If you need me, you know where to find me. They have 2 links, so they go to both top-of-rack switches, which are actually routers, and they announce their routes. Jumbo frames enabled, 9,000 on the MTU on all the hosts. So the network itself is running at 92.16, and we run at 9,000 on each host. And the beautiful thing with IPv6 is you have mandatory MTU path detection. So it makes sure if that host communicates with the internet, it will use an MTU of 1500. And if it communicates internally, it will use an MTU of 9000. With IPv4, it's not mandatory to have path detection. IPv6 has mandatory MTU path detection. So, pretty simple BGP configuration. If you are familiar with the configuration, I took a few things out. Every host, in this case it's a hypervisor called hypervisor 138A0523. The way we use our naming for our devices is that it's a device type, then the room in the data center, so 138 in this case, it's the number of the room, A05 is the rack, and then 23 is the unit where it's in the rack. So there's no label in the rack, on the machine in the rack. We know based on the unit where the machine is. If it's a multi-U machine like 2 or 3U, we'll use the top U. But based on the host name, we know where the machine is. If we indicate it's a hypervisor by using HV, an OSD machine will have OSD as the first in there. That's what it has. That's all we do. And then in this case, XXX, that would be, for example, AMS02 or AMS03, indicating one of our data centers. So you won't find labels in this new deployment. Yes, of course, we have some older things which still have labels, but we found that after a few years, the labels would become yellow, or the glue would come off. They would fall off, and there would be all kinds of labels on the bottom of the racks. So that's why we don't have them. So on the loopback device, we have a single IPv6 address. It's being announced. Then it has its own AS number. So we use 32 bits AS numbers, private AS numbers, and they announce it. And over both interfaces, they create a BGP connection towards the top of rack. And then here it announces its own address again to all the neighbors. And then that's it. That's about all the configuration which we have on a Ceph machine. It's a bit bigger, but this is about all the configuration we have on there. Same goes on a hypervisor. But you might be wondering, if you're using BGP, how do you actually get the peers set up? Because you usually need to set up the addresses from both sides with BGP. So there's something very fancy which is supported by BGP and Cumulus called BGP unnumbered. And by using BGP unnumbered, each host creates 2 sessions. So one session with one top of rack and a second session with a second top of rack. But it uses the IPv6 link local addressing. If you open a server and you look at the interface of a machine, you'll see these FE80 addresses on your device. You might be wondering, what are those? Well, those are IPv6 link local. And BGP unnumbered creates BGP sessions ad hoc over IPv6 link local. If you enable saying on this port I'm allowed to create BGP sessions, it will just set up a BGP session whenever it finds a neighbor on that network. Since there's only one neighbor, because there's one wire going from the host to the switch, they will establish a BGP session. They'll become neighbors. So if you look, BGP neighbor on ENP8, and then there's the name of the interface, and then FE80, that's the link local, and the remote autonomous system is then the autonomous system of the router running on top of the rack. And then local autonomous system is again a different number. And then host name, it says TOR, top of rack again, 138 A05 46, so I know this router is running on unit 46 in that specific rack. Local host again, its own link local address, and then the foreign host, the other link local address. So they built these BGP sessions without us needing to actually administer different addresses for all the peers on the different hosts. So plugging in a host, it's just plugging in the host, getting the configuration of BGP on there, it announces an IP, and it works. And there's no layer 2, no LHCP. BGP does the balancing over the two links. If a link goes down, the session is gone, and then we will no longer be using that link. So it's complete layer 3, and that's pretty scalable. I created a diagram. I know it says blade chassis in the picture, but it was just easier to do a blade chassis than have a bunch of machines there. But you'll see that we have the Dell switches, the 100 gig switches, 2 times as for a deployment. It says internet, not completely true. We have our Juniper MX series, which do the real BGP to the outside world. So they connect to our Juniper routers, which are pretty static. And from there, all the flexible VXLAN stuff starts. In a Ceph rack, we'll have 2 top of rack. This is the 5248. So that's a different Dell switch, but also running Cumulus Linux. And then we have the Dell with the 100 gigs, which are on top of rack for the hypervisors. So yes, we have 2 times 100 gigs going into each hypervisor, mainly because we figured 25 was okay, but 100 gigs was not so expensive anymore. So it was easy to go for 100 gigs to make sure we have enough bandwidth. We don't use it. It's not that we need 100 gigs going into the hypervisor, but it's future-proof. Ceph still on 10G, and then we have those hypervisors in there. The amount of hypervisors we can fit inside a rack, that is actually depending on the amount of power we can consume in that rack. So we put in as much hypervisor as we can, but we have 32 ports and on a switch, so the maximum will be 32, but I think they draw like 500 watts each, so it's no way we can fit 32 of those hypervisors inside a single rack. No, not going to be working for us. So scaling, we scale out by building multiple Ceph clusters. So if we have storage, and if you look back again, we have a rack, and this rack will be 1 Ceph cluster. That will be 3 monitors, and then as much as Ceph machines as we can fit in. The reason why we do so is that we want to make sure that if something goes wrong, for me it's always a matter of not something if something goes wrong, when it will go wrong. Something will go wrong. Ceph is awesome, it's a great technology, but there's just one admin making a mistake and then the Ceph system goes down. So we choose to just scale out multiple Ceph clusters in a single rack, and I have a slide coming up about it, how it says. CloudStack easily supports multiple Ceph clusters. There is something called primary storage inside CloudStack, and we can attach as many as we like. Of course, there's a limit somewhere, but as many Ceph clusters as we like, we can attach it to CloudStack and just say, you know, if you want to allocate a volume, just use any of these Ceph systems, and they are well connected. Because again, all the Ceph clusters go back to the 100 gig Dell switches, and from there we just keep scaling out with more Ceph clusters, and as we need more hypervisors, we scale out more racks with hypervisors. One thing I forgot is that if a machine is running, is installed on unit 23, it will use switch port 23 as well. So we actually completely know where a switch is connected. The same goes for the IPMI. There's one IPMI switch, 48 ports, you will go on port 23. So scaling out, VLANs are no longer a problem because we don't have layer 2. It's all BGP with VXLAN. And so we can add as many hypervisors as we think CloudStack safely supports. We are now managing, I think, with the biggest deployment, about 200 hypervisors with a single CloudStack manager. And then also we start separating into different CloudStack managers because although CloudStack might be able to scale, if somebody makes a mistake, we don't want the whole cloud to go down. So we simply built multiple CloudStack deployments just to prevent that from happening. And as I said, the hypervisors can be spread out over multiple racks because VXLAN will just make sure that it's routed with BGP to the right location. So the maximum per rack is about 5 kilowatts. So yeah, we can usually fit 10, 11 hypervisors inside a single rack. So with VLANs we had to be conservative, and with VXLAN we no longer need to be conservative. How am I on time, Steve? I got 15? I'm perfectly on time. Yeah, I figured so. Because one of the questions customers said is they want us to route their IP space to their VM. So they have their own IP space. They want us to announce the BGP through BGP to the internet, and then we can route their IP space to the VMs which we run. So that was one of the drivers, the main drivers where we don't have enough VLANs inside a data center. So that's why we want to use VXLAN, and now we can do so easily. Just create a new network, create a new VNI, route the IP space into that VNI, and then tell CloudStack, use VNI 8,000, and this is the IP space which you can use, and then VMs get IPs allocated from CloudStack, which are from the customer. So you only see our network in the traceroute if you would do so, and they could be co-located in our data center. Nobody would know they're actually on our cloud deployment, but they're just VMs running on our cloud. And we can set additional traffic policies if we need to. Some customers say, hey, I want you to filter away all this traffic on the highest level possible, so we filter away their traffic. So, but the Ceph clusters which we use, again, like I said, there's one cluster per rack. So if a rack goes down, we lose a complete Ceph cluster. Of course, the redundant power, A and B, going into the rack, 3 months, and then as much OSD machines as we can safely fit in that rack. Once we reach the power limit, we simply go to a new rack. With the 4 terabyte NVMe's, we get about 650 terabytes of raw Ceph capacity inside a single rack. We are now thinking about going towards 8 terabytes of NVMe's, but that would be 10 times 8 terabytes of NVMe inside a single machine. And again, we are trying to mitigate risks. Yes, we are looking for the lowest price possible, but also mitigating risks. If you have this gigantic 1.2 petabyte Ceph cluster in one rack, if that goes down, admin makes a mistake, or something goes wrong with the network, we'll have a lot of customers calling us. So we're also trying to balance between how much can we handle, how many customer calls can we handle at the same time if something goes down. So it's not only a technology question, but also a question, can the organization, can the help desk handle that amount of calls, emails, chats coming in if we suddenly lose like 5,000 VMs because a Ceph cluster goes down? I'd rather have half the clients go down. So it's a balance between price and manageability of the system. But if we would need, we could also deploy a HDD only Ceph cluster. We have one of those running where a customer really wanted to have a lot of HDD storage, so we just have one rack running a Ceph cluster with HDD storage. Again, the flexibility of CloudStack allows us to simply connect that system to CloudStack, and then using some tagging on the storage, we can allocate specific volumes on specific storages. Then everybody wonders about performance. I would say it's excellent. It works as intended. The Dell switches are super fast. We can saturate the 100 gig links easily. And we achieve about a 0.8 milliseconds write latency on Ceph. That's a 4K write with 3 times replication on those NVMe devices, all going over the 10 gig and the 100 gig links. And we see about a 0.2 millisecond latency, 0.15, 0.2 latency between the hypervisors and the Ceph storage. So we would say it is actually...
Is that latency at maximum hours? Or every time?
No, this is not guaranteed. It happens every time.
This is not 99.9%.
No, of course. If you start to saturate the storage at some point, of course, the latency will jump up. But this is what we see. If I do the test now with a system which is running in production, I still get this latency. But of course, it fluctuates a bit slightly depending on the workload coming in. There's not much you need to do. There's one thing you need to think of, is that you need to set the public adder in the ceph.conf to tell the Ceph daemons to bind on that specific address when they start. Otherwise, they won't find an address to bind on, and they refuse to start. So make sure that you set the address which is on the loopback device is actually configured in Ceph. There's no further configuration needed for BGP. That is true, of course. We have different configurations to slightly improve the performance, like disable all the logging inside Ceph to just lower the latency for the Ceph daemons. So I would say with my conclusion is that it is a scalable networking solution without using VLANs. So there are no VLANs in this deployment, only VXLAN. And we can easily scale out. We can just create multiple networks for customers if they need to. And we can add more hypervisors and Ceph storages as we like. And that's the way we can keep scaling out. At some point we will say this deployment is now too big. We'll build the same deployment again inside the same data center. That's probably about 4 or 5 Ceph clusters and then 4 or 5 racks full of hypervisors. And we'll build a new deployment just to make sure that if something goes wrong, it goes wrong in a specific part of the network and not on all parts of the network. So that's mainly my message I wanted to give you, is that we think we can build a scalable network. We could create 60 million VXLAN networks, VNIs, but we don't do that because we want to prevent everything going down at the same time, causing a major disruption for our customers. Yeah, it's a high-performance Ceph environment providing reliable storage. One thing I forgot to add to the slides is that if you use CloudStack 4.13, there is also live storage migration for local storage with KVM. So we have these hypervisors with local storage with NVMe, and we can now also live migrate virtual machines between different hypervisors.
I recall that was also available in 4.12, but only with root disk. Is this now supported to also like migrate data disk?
No, live migrate data disk. That's actually a KVM thing which doesn't support it. That's the drawback.
All right, but if you say dash migrate migrate all storage or copy all storage.
Yeah, we are still looking into that because it could be that if you have a Ceph storage attached, that KVM gets confused because it will then try to migrate that data disk to a different storage. Yeah. So currently there's still an if statement telling you that only with the root disk it's allowed to migrate. Yeah.
Cool.
And yeah, thanks. I'm actually 10 minutes ahead of time. Though I was afraid this morning I wouldn't make it within time. But before I see some hands with some questions. Sven.
How do you monitor your infrastructure? So you have lots of hosts, lots of hypervisors.
Yeah, we use Zabbix. Yeah.
And for VMs as well?
Well, we don't monitor the VMs because that's the customer's responsibility. So we do some monitoring using the QEMU guest agent, where we just pull some information from the VMs, but it's very basic information because we don't want to go into the VM of the customer without their permission. But we use Zabbix to monitor all the hypervisors and the Ceph machines, and we have some external tools like simple uptime robot where we just sometimes we have a few websites of customers which we know, and we'll just start monitoring those websites. Just if they go down, that we actually get an alert, and it might be a network problem. But it's mainly Zabbix which we use for monitoring. Yeah. Well, one question here. Yeah.
How many OSDs do you have per whole cluster, sub-cluster? How many OSDs hosts?
Hosts. So if you go back to the Ceph hosts which we have, this one, so there will be 10 OSDs on a single machine, and we have about 15 to 17, so 150, 170 OSDs in a single cluster. Yeah. Thomas, you had a question.
Yeah, just the vertical overhead. By comparison, you're adding enormous extra layers. What is do you have an idea about what in terms of your holding up your packets, how much extra overhead there is, adding headers and that kind of stuff? Is it quite substantial? Or?
No, I don't think it's substantial because all the VXLAN stuff is done by the chipsets on the Mellanox cards and the hypervisors. They have VXLAN offloading, and the Ceph storage itself, that's not routed through VXLAN. So the hypervisor just talks to the Ceph storage over BGP or over BGP or layer 3, but it's not encapsulated. So it's only the VM traffic of the virtual machines. But I didn't see any noticeable increase in latency. No.
So
Question.
My understanding was that actually Cumulus at the moment cannot do IPv6 for the underlay. So you're running IPv6 for the underlay. I actually have a ticket with them where they confirm that it doesn't work. Do you know if that's chipset specific?
Yeah, that's chipset specific.
Because I'm using Mellanox Spectrum, not Triton 3.
Yeah, it's a
V4 works, V6 doesn't.
Okay, but it's a Trident 3 thing.
In your case, yes. For
Yeah,
me,
yeah. So
do you think Trident supports it?
Yeah. Trident supports it. Yeah.
That's a good advantage.
Yeah, but still, if you still need to announce that single IPv4 address for just the underlay network, you can choose any address you like, and it just works. But the Ceph storage would be IPv6 only. It's just for the hypervisors which need a layer 3 connection over IPv4 for their VXLAN traffic.
I also noticed that you put actually the IP into the FRR conf.
Yeah.
You could just announce the interface, right? And then you don't have to have an IP.
That's correct, because we use Salt to manage all the configuration. So we just, it comes from the pillar data, as it's called in Salt, and we just put it in the configuration just to make sure it's in there. Yeah, but thanks for the note.
And is that upstream FRR?
Yeah, upstream FRR, yeah. Yeah.
How do you ensure some kind of quality of service to it?
We don't guarantee a certain quality of service on those networks, so it's all just we just make sure there's enough bandwidth on the routers and switches to make sure it handles the traffic.
How do some stupid client run some stupid MySQL on your infra?
Oh, that way. So
Storage.
storage-wise, we do set I/O limits in KVM towards the Ceph and the local storage. So there's the burst I/O. We set a burst I/O. So if you start doing, you can do a lot of I/Os, and then you'll be limited after 3 minutes down to a lower level. We communicate those limits with our customers as well, telling them this is the burst I/O limit and this is the base I/O limit. And the same we do with the network. You'll be limited to, I think, 1 gigabit or 5 gigabit of traffic per VM, just to make sure that it's not a single person who can saturate the whole network. Okay, if there are no more questions, then thank you, and let's go to the next speaker.